Jai Hind dear students, welcome back to Mathematics online class. We are doing the chapter Polynomials, and in the previous class we learned about different types of polynomials, linear polynomial, quadratic polynomial, cubic polynomials, and also we learned how to find the zero of a polynomial, how to find the value of a polynomial, and we did some related examples. So hope all of you completed your notes and homework. Now we are going to see the next section of this chapter. Okay? Yes. For that, before we start the topic, you all know what is the general form of a linear polynomial. So we can say that a linear polynomial is of the type, a linear polynomial is of the form ax plus b, where a not equal to 0. So this is the general form of a linear polynomial. So consider an example. Consider 2x plus 3. So you know that this is an example of a linear polynomial. Now if you need to find the zero, a linear polynomial is having only one zero. So to find the zero of this linear polynomial, we want to equate this to 0. So you will get 2x plus 3 equal to 0. From this, what is the value of x? 2x equal to minus 3. X is equal to minus 3 by 2. So this is the zero of this given linear polynomial. Now from this example, we can generalize how to find the zero of a linear polynomial of the form ax plus b equal to 0. If you want to find the general zero, we are getting ax equal to minus b, x is equal to minus b by a. Now you know children, what is this a? A is the coefficient of x and b is the constant term of the polynomial. So by using this relation, we can find out the zero of any given linear polynomial. Okay, so this gives you the relation between zero. 0 means this value of x. So x is the zero of this linear polynomial. So 0 and what is this a and b? They are the coefficients. So we will get the relation between 0 and coefficients of this linear polynomial. So what is the relation? X is equal to minus b by a. So this gives you the relation between 0 and coefficients of a linear polynomial. So now we are going to see how we can find the relation or how we can find the zero of a linear polynomial using this relation. Okay, so let us see one example. Yes, your first example, consider a linear polynomial 5x plus 3. Okay, so this is a linear polynomial. Now from this, what is the value of a? It is 5. What is the value of b? It is 3. Now using this relation, we can find the zero x. So that x is equal to, what is the formula? Minus b by a. Now put these values using, so we will get x is equal to minus b value is 3 by a is 5. Okay, so in this way we can find out the relation between x and minus b by a. We can find the value of x. So you can see from here x is equal to minus b by a. So x is equal to minus 3 by 5 is the zero of this polynomial. Now come to the next example. Yes, question number 2. Consider the polynomial 5x. Okay, so 5x is also, it is having only one term. This is also a linear polynomial. Now how to find the zero of this linear polynomial using this relation? you know that in 5x there is only one term, the x term is present. See, x term is present and the constant term is absent. So when the constant term is absent, we can put there a 0. So constant b is 0 and a is 5. So here a value is 5 and b is 0. Now how to find the value of x? Yes, using this relation x is equal to minus b by a, we can put minus b value is 0. So 0 by a is 5. So again 0 by any number is 0. So x value is, therefore x is equal to 0. So in this case the value of x is 0. So this case is when the constant term becomes 0, then the linear polynomial value minus b by a also is equal to 0. So now one more example. Yes, consider the linear polynomial which is having the b term I am taking as negative. So 8x minus 2. Now children, you can see that here the constant term is a negative value. So first you want to write what is a and b. A is here coefficient of x 8 and b is a negative value minus 2. Now when you want to find the 0, we will use the relation x equal to minus b by a. That is, minus is here already in the relation and then b value is having again on minus side. So you want to use the bracket. Minus of minus 2 divided by a is 8. So that minus of minus becomes plus. So it is 2 by 8. You can reduce 2 by 8. So it becomes 1 by 4. So thus we get the value of x is 1 by 4. So these are all the cases we have discussed. How to find the relation formula using, we can find the 0 of the linear polynomial. Okay, I hope you understood the examples. Now students, we can discuss about the quadratic polynomial, how we can find the relation between the coefficients and zeros of a quadratic polynomial. So let us consider a quadratic polynomial 2x square minus 8x plus 6. So this is a quadratic polynomial where you know the coefficients are x square, the coefficient is 2, the coefficient of x is minus 8 and the constant term is 6. Now if you are asked to find the zeros of this quadratic polynomial, how will you do? You need to do the factorization method to find the zeros of this quadratic polynomial. So for that, you know, in a quadratic polynomial we need to use the splitting the middle term method to find the zeros of this polynomial. Okay, so for that, what is the product value? Here x square is having the coefficient 2, so that 2 into 6 is the product value, that is 12, and the sum is the middle term, that is minus 8. So sum is minus 8. So what are those two numbers that is having product 12 and sum minus 8? So you know that we have 2 into 6 is 12, and to get sum minus 8 we need to take negative of 2 and negative of 6, that is minus 8. So our required two numbers are minus 2 and minus 6. So using these two numbers we are going to split the middle term of this quadratic polynomial, and you know that to find the zeros we need to equate this quadratic polynomial to 0. Okay, yes, now using the two numbers we are going to split the middle term. So this implies 2x square. What are the two numbers? Minus 2 and minus 6. So minus 2x minus 6x plus 6 equals 0. Now we need to pair the terms so that regrouping by we can find the zeros. So this implies, what is the common term here? 2x. So 2x into x minus 1 minus 6 into x minus 1 equal to 0. So what is the next step? Here you can see that x minus 1 is the common factor. So x minus 1 into 2x minus 6, the remaining terms outside, equal to 0. Now you can separate these to 0. So it becomes x minus 1 equal to 0 and 2x minus 6 equal to 0. From this you are getting x is equal to 1 and here x is equal to 6 divided by 2, that is 3. So thus we got the zeros. You know that a quadratic polynomial is having at most 2 zeros. So here the 2 zeros are x is equal to 1 and x is equal to 3. Okay, so you know this method of finding the zeros of the quadratic polynomial. Now using these zeros we are going to the next section, that is consider these 2 zeros of this quadratic polynomial. If you are finding the sum of the zeros, what you will do? We will add these two numbers. So you are getting 1 plus 3 equal to 4. Okay. Now if you multiply these zeros, that is product of the zeros, that is 1 into 3. 1 into 3 is equal to 3. So the 2 zeros we considered the sum and the product. Now we are going to find out what is the relation between these zeros and the coefficients of a quadratic polynomial. For that we want to generalize. The quadratic polynomial can be written in general form as, what is the general form of a quadratic polynomial? Ax square plus bx plus c, where a is not equal to 0. Now here you can see that c is the constant term, b is the coefficient of x, a is the coefficient of x square. Now what we are doing, here we got sum of the zeros. Sum of the zeros is equal to 4. Okay, and I took the quadratic polynomial is 2x square minus 8x plus 6. This is the example what I took here. So in this you see this is equal to 4, that is sum of the roots equal to 4 I got. Now I am writing this 4 as minus of minus 8 by 2, that is minus 8 is the coefficient of x and 2 is the coefficient of x square. So what is the answer for this? Minus of minus 8 is plus 8, plus 8 by 2 is equal to 4. That means sum of the zeros can be written as minus of coefficient of x divided by coefficient of x square. So we are getting minus of coefficient of x divided by coefficient of x square. Okay, so when you find the sum of the zeros, the value will be equal to minus coefficient of x divided by coefficient of x square. What is the minus coefficient of x is? You know that it is equal to b in general form, and coefficient of x square in general form is a. So that we can write this as minus b by a. So this is the relation to find the sum of the zeros. If you need to find the sum of the zeros of a quadratic polynomial, the relation is minus b by a. Now you know that in a quadratic polynomial we have discussed there are two zeros, so that in general let the two zeros I am considering, one as alpha and another as beta. Okay, for any quadratic polynomial you know that there are two zeros, and one zero I considered as alpha, the other zero I considered as beta. Now can you say what is sum of zeros? Sum of zeros is equal to we will add this. Okay, so alpha plus beta, and that will be always equal to what relation? Minus b by a. Minus b by a, where b is the coefficient of x and a is the coefficient of x square. So this is the first relation between the zeros and the coefficients of a quadratic polynomial. Now the similar way we can find the product of the zeros. So product of the zeros, as I discussed earlier, what do you get the product of the zeros from this previous example? 1 into 3. 1 into 3 is equal to 3. So this 3 I am going to write as, this is equal to, here you can see the constant term is 6 and the coefficient of x square is 2. So if I am writing this as 6 by 2, you are getting the answer 3. That means 6 is the constant term and 2 is the coefficient of x square. Coefficient of x square. So thus we can find for any quadratic polynomial, product of the zeros is always equal to constant term by coefficient of x square. In general form, what is the constant term? C. So that is equal to C by coefficient of x square is a. So it becomes C by a. So therefore we can say for any quadratic polynomial, product of the zeros is equal to C by a. Now we can say it in terms of alpha and beta. So if the alpha and beta are the two zeros of any quadratic polynomial, let alpha and beta be zeros of a quadratic polynomial. Then how we can find the product of the zeros? Here sum of the zeros we wrote as alpha plus beta. So product of the zeros equal to product of the zeros. We can write alpha into beta, that is alpha beta. Alpha beta is equal to what relation we got? Constant term by coefficient of x square, that is C by a. So this is the second relation you are having for relation between the zeros and coefficients of a quadratic polynomial. So the first relation is between sum of the zeros equal to minus b by a. The second one is product of the zeros equal to c by a. Now using these two relations, we are going to see more examples.
Dear students, now let us conclude what we learned in this module. In this module, we learned about relationship between zeros and coefficients of a polynomial. For a linear polynomial ax plus b where a not equal to 0, 0 of ax plus b is given by minus of constant term by coefficient of x, that is equal to minus b by a. For example, if you are considering the 0 of 2x plus 3, it will come minus 3 by 2. For a quadratic polynomial, the zeros ax square plus bx plus c where a not equal to 0, and we consider alpha beta as the zeros of this quadratic polynomial, then sum of the zeros alpha plus beta is equal to minus coefficient of x by coefficient of x square, that is equal to minus b by a. Product of zeros alpha beta is equal to constant term by coefficient of x square. So all of you thorough these relations between the zeros and coefficients of a linear and polynomial and a quadratic polynomial and practice very well. Now in the second video of today, we will discuss some more examples from this type of relation between coefficients and zeros of polynomials. So hope all of you understood this video. Thank you.